So as an example of why machine learning can be an important tool for EV battery simulation as well as test, let's start with a simple example of an EV battery simulation. The simulation here has three inputs, so it's a simple case. There's the flow rate of liquid coolant, there's a thermal conductivity input value we can control, and there's a value for the ambient temperature. So now, of course, in the real world, all those inputs are going to be subject to some uncertainty. So it could be of large interest to us to understand the uncertainty in the output of that simulation, the maximum battery temperature that results from the uncertainty in those different inputs that's going to be present in the real world case. And we can do something like that with a technique called uncertainty propagation. And uncertainty propagation itself is a method. Algorithmically, it is fairly straightforward. I'll explain it here in a moment. It's relatively easy to implement, but it is a statistical method. And so what that means is, typically it requires fairly large samples of data in order to deliver accurate or, effective results. In this example, where we have three inputs, that's saying, we might need to run this simulation 3,000 times to get the results for this uncertainty propagation. And even if this is a simulation that runs pretty quickly, let's say 1 minute per simulation, that means it's going to take 3,000 minutes to run this one analysis, which is over 2 days. So it's not practical to do that. We could do it if it was of large importance, but eventually if we start looking at problems where it's taking an hour per simulation run, or there's many more inputs, it becomes infeasible to imagine doing something like this. So the solution to all this comes back to the whole idea of machine learning, and the solution we tend to refer to as surrogate modeling, at least when we're talking about it in a simulation context. But essentially, rather than running the EV battery simulations here to conduct the analysis itself, the uncertainty propagation, we actually run those simulations to collect data that we're going to use to train a machine learning model of the simulation. And once we have a machine learning model that can quickly, accurately predict the results of that simulation without needing to run it, we've essentially removed any sampling requirements associated with the analysis, which would be, again, uncertainty propagation in this case. We can do those 3,000 samples, virtually instantly. And a similar idea to this applies to, test data for EV batteries, where we can train a model, capable of predicting the results of tests we haven't conducted, and then use that model for various analyses.